Hello there. My name is Trevor Judd, and I'm a test automation engineer. I've created this course to help seasoned developers and new engineers alike learn how to apply test automation techniques to optimize their workflow. This optimization is achieved best by automating software testing that has traditionally been done manually. What is test automation? Test automation is a method in software testing where scripts carry out tests on an application before it is released into production. The goal here is simple: ensure that the software behaves as expected, and this is achieved by writing test scripts that can be run automatically. Flow of control is determined by the automation software you use to execute the scripts. The results are then compared with expected outcomes to decide whether the code will go further into production. Why should we want to automate software testing? Manual testing becomes more challenging as scalability increases with software requirements. At ever larger scales, there is more potential for human error working against reliable and consistent test results. While manual testing may be essential in better understanding the user experience, developers can't carry out bulk tests manually with speed or great efficiency. Therefore, it becomes crucial to automate these tests with the help of scripts. Automated tests can run quickly, are repeatable, and can be run on multiple environments and devices simultaneously, which is a significant advantage over manual testing. Manual testing requires a team of human engineers to conduct tests on the application. Human operators are error-prone and unreliable at large scales, and they take a lot of time with little return on investment. With automated testing, we eliminate human error. We can expand our test coverage at larger scales, save time, and improve efficiency. By automating regression testing, load testing, and performance testing, we can free up the manual test team to do ad hoc, usability, and exploratory testing, which are tough to automate. The core components of automated testing include test scripts, testing frameworks, test cases, and test data. Each component plays a crucial role. For instance, test scripts are the actual codes that automate the testing actions. This course includes lessons in writing test scripts like the one displayed here. Frameworks like Selenium Python provide the backbone to write and run these scripts effectively. There are also different types of frameworks. The linear framework type is a basic framework where testers write and test scripts for individual cases by recording and playing back their actions on screen. The modular-based framework type is used to organize each test case into tiny parts called modules. These modules are independent and can be organized uniformly using a master script, usually called a test plan, saving time and optimizing workflow. This is the framework I like to use the most, and so most of my demonstrations will involve showing you how to write modules and organize them into a test plan. The library architecture framework type is built on a modular framework. This approach breaks down test cases and groups tasks within a script into different functions stored in a library. This type is great if you want flexible and reusable test code. A data-driven framework involves test cases that are written around a data set rather than a set of steps. This can be useful if a project is under time pressure or has very large test cases. The typical data-driven framework includes a suite of test steps, each containing all the information needed to execute that step against a dataset. In a keyword-driven framework, the implementation of a system is separated from its specification and implementation. An interface contains method names without any associated implementation, and the implementation of the specification is represented as an interface stub that contains the implementations but does not expose the code that implements the methods. A hybrid testing framework combines manual and automated tests to achieve the highest quality software possible. This framework utilizes the human-readable feature files of behavior-driven development, the unit tests of test-driven development, and the acceptance tests of acceptance test-driven development. Even though we can automate tests like smoke tests and regression tests, some tests might need human interaction. Therefore, we can separate tests into automatable and non-automatable categories. Automatable tests include things like regression tests that must be run against every application build and/or release, tests that use the same workflow but different input data for every test, performance tests, tests that take very large data sets as inputs, tests that take a long time to run, and tests that are very important to your product. Non-automatable tests include tests that only need to be run once in a lifetime, user experience tests that involve human opinion, ad hoc testing that requires domain expertise, tests with unpredictable results, tests you don't need to watch in order to ensure that the results are consistently right, and tests that don't focus on the risk area of your application. Testing is the backbone for attaining high-quality software, and test data is the core element in the process of testing. Test data provides information to the tester that facilitates finding defects and corrective actions. Typically, we need to create the data, or at least identify it based on the type of requirements each project has in the very beginning. Test engineers not only collect and maintain data from existing sources, but they also generate volumes of test data meant to ensure a quality contribution when delivering the product to the customer. Therefore, automated test engineers must develop a strong understanding of the most efficient approaches to test data collection, generation, and maintenance. Automated testing can be separated into two categories: functional and non-functional tests. Functional testing checks if an application's features meet the software requirements. Tests in this category ensure delivery of consistent results that align user expectations for performance and experience. It involves testing by providing inputs and checking if the outcomes match what users expect. Unit testing is done by developers while they're writing code for an application. The main goal of unit testing is to check that each method of an application works correctly. Integration testing ensures that a system's various modules and components function correctly when combined. For example, microservices often interact with other microservices. Integration testing aims to guarantee that these microservices communicate properly and operate as intended. Regression testing is performed whenever an alteration is made to an application. A code change or the addition of a new feature risks disrupting existing functionality. Regression testing aims to ensure the stability and continued performance of the software. Smoke testing serves as an early-stage acceptance test, ensuring that the most critical and essential functionalities produce the intended results. It adds a layer of verification to decide whether a new software build should progress to the next stage. Like regression testing, sanity testing is performed on new software versions with small bug fixes or added code. If the new build doesn't pass sanity testing, it won't proceed to further testing. Unlike regression testing, which looks at the entire system after changes, sanity testing focuses on specific areas affected by new code or bug fixes. Unlike functional testing, non-functional testing evaluates an application's performance, usability, dependability, and this type of testing aims to ensure the software meets non-functional criteria, such as reliability and efficiency. Performance testing ensures that the software meets its performance goals. This includes testing the application's response time and throughput. This type of testing reveals how various factors such as network latency, database transaction processing, data rendering, and load balancing between servers impact the application's performance. Load testing is an aspect of software testing that evaluates the stability of an application while it's under a specific load, typically equal to or less than the anticipated number of users. For example, if an application is designed to handle 300 users simultaneously with a target response time of 4 seconds, load testing is conducted by applying a load of up to 300 users. The goal is to confirm that the application maintains the desired response time of 4 seconds even when subjected to the specified user load. The security testing process checks the software application's or system's resilience to cyber attacks and unauthorized access. Accountability testing aims to verify whether a system functions as intended. It ensures that a specific function delivers the expected outcome. If the system produces the desired results, it passes the test. If it doesn't, it fails. Reliability testing involves running the system for a specific period of time and under certain processes to evaluate its stability. The reliability test will fail if the system encounters issues under predetermined circumstances. For example, reliability testing a web application ensures all pages load properly and links work without errors, ensuring a reliable user experience. Stress testing aims to verify that a software application or system can withstand unusually high loads or demands. For example, stress testing could involve subjecting a web application to many users attempting to log in at the same time. Usability testing ensures an application or system is user-friendly and easy to navigate. This type of testing assesses the overall user experience. Volume testing verifies that an application or system can effectively handle a substantial volume of data. If a website is designed to handle traffic from 1,000 users, volume testing assesses whether the site can manage the specified volume without experiencing performance slowdowns or data overloads. Compatibility testing checks whether a software application or system is compatible with other software, operating systems, or environments. During compatibility testing, a tester ensures that the software functions without issues when it interacts with other applications and operating systems. The benefits of automated testing are immense. It increases your test coverage, saves time in the long run, and reduces the likelihood of human error. Developers can use automated tests to execute a large number of test cases very rapidly. More test cases ensure maximum coverage of requirements and features in every test cycle. Better test coverage increases the probability of finding bugs, which, in turn, prevents production issues from showing up further down the pipeline. Automated tests complete the defined manual steps precisely every time they are executed and never fail to record detailed results. Test automation reduces overhead. Scripts can be easily updated and reused as the application evolves, minimizing the resources required for regression testing and allowing teams to focus on more complex scenarios. Automation helps reduce a manual test team's workload. Manual testing can't execute repetitive tests like regression tests, and as an application grows more sophisticated, new features must be tested, making more work for the manual testers. Test automation permits testers to divest themselves from repetitive testing. Instead, they can focus on more important tasks like designing new test cases and test scripts. Automated test scripts are reusable assets that can be used across multiple testing cycles and projects. Once a specific test case has a script written for it, the script can be adapted and reused to test similar functionalities, thus speeding up future releases. Automated testing is not without its challenges. It requires an initial investment in time and resources to set up, and maintaining test scripts as the application evolves can also be demanding. A major worry for software teams with tight budgets is the upfront cost of starting up an automation suite. In addition to daily operating costs, there might be additional expenses for software licenses. This is easily solved with the use of open source tools such as Selenium, which do not require licenses, and the time cost can be offset with practical training exercises like those found in this course. It's important to collaborate so that knowledge is shared between members of a development team. Another challenge is communication. Test automation can be an intensive investment, albeit one that pays potential dividends. Getting everyone on board involves effectively communicating objectives, providing data and proof of concept, and outlining clear goals. Designing and implementing test automation requires a specific skill set. Thinking that any developer or tester can handle test automation is a mistake. Recognizing that test automation requires special skills and knowledge is important. Organizations should avoid thinking any developer or manual tester can handle automation. Instead, hiring automation engineers with the specific skills needed for designing and implementing automated tests can be a prudent investment. 100% automation isn't a realistic goal. A common cause of test automation failure is a desire among management to automate everything, but certain aspects of software testing require human intervention to prevent errors and ensure timely releases. To overcome unrealistic expectations, the test automation team must set achievable goals and educate management about the limitations of automation. Critical test cases should be prioritized, and open communication with developers and manual testers must be maintained so that expectations don't inflate beyond what is deliverable. Creating automation tests involves more than choosing the right tools. It requires a testing approach that aligns with your software development process. Software testing within agile development is complex and requires strategies to identify changes and adapt to those changes with minimal maintenance. Testers and developers should minimize script implementation and maintenance by adopting modular design and testing frameworks that support easy updating. Ensuring the long-term effectiveness of automated test suites involves regular reassessment and updates in accordance with application changes. Version control systems like Git should be used to track modifications to test scripts. Valuable test reports requires the implementation of reporting tools within the chosen framework. Agile testing practices and a robust version control system can help an automation team adapt to agile software development. Achieving accuracy in testing relies on maintaining relevant and precise data. Running tests that use old data can produce inaccurate results. To meet this challenge, teams should implement regular data updates, maintain communication with other teams, and develop robust analytical solutions to enhance overall productivity. Test automation engineers often face challenges with false positives and false negatives. The best way to reduce this flakiness comes down to a thorough understanding of the application being tested and its intended behavior when fed certain types of input. This understanding can be best achieved by communicating with manual test and developer teams. Automated test scripts often fail due to synchronization problems. These occur when testers anticipate a certain event, but it gets delayed or doesn't happen as expected, and this usually results in a timeout error. The most common solution is to use a combination of implicit and explicit waits, which help synchronization issues during script execution. Testing complex applications in various environments, especially using regression tests, is time-consuming. Customers expect quick product delivery to stay ahead of their competition. This pressure often leads to rushed testing, prioritization issues, and insufficient test coverage, all of which let bugs make it into production. To meet this challenge, teams should review and prioritize test cases. Each one should be evaluated to identify which cases benefit from automation and which cases require manual execution. Striking a balance between manual and automated testing is key to success. Adding more tests slows down the test automation process, causing delays, missed milestones, and disruptions in release cycles. Prioritizing test cases is crucial to improving efficiency. To address this problem, teams should consider increasing simultaneous test executions or prioritizing which tests to automate first. Prioritizing tests helps identify critical areas early, saving time and ensuring thorough testing. To sum up, automated testing is a powerful approach that can significantly improve the quality and efficiency of software development. Although it calls for a significant upfront investment in manpower, planning, and setup, in the long run, automation ultimately saves time, frees up personnel, and increases productivity and efficiency during the software development lifecycle. Thank you for watching. If you have any questions or comments, please leave them below. Don't forget to like and share this video if you found it helpful.